I start with symbols that automatically have meaning. And, not, I have no idea who came up with these, by the way. Or, implies, basic logical things, exists for all, and I have myself parentheses as well. Because when I'm writing something, I kind of need parentheses. And then, I also have myself an equals sign. Because I want to be able to say that two things are equal. And I have variables, x, y, q, frowny face, etc. And that's it. That's what I have all the time. That's sort of the grammar of logic. And then I have whatever vocabulary I might be using. I might be talking about addition, in which case I really want a symbol for plus. I might be talking about the natural numbers, and I might want to be able to multiply them, in which case I want times, right? Maybe I want a little caret symbol for exponentiation. Maybe, because I'm being stupid, I want a three-place relation that you plug things into that always holds. So no matter what things I plug in here, this relation always is true. It's a stupid relation. Maybe I want it, I don't know. Maybe I want a relation for less than. Takes in two inputs, right? I give it two numbers, it holds or it doesn't. Whatever vocabulary I need to talk about what I'm talking about, which depends on what I want to talk about at the moment. This part changes. This part doesn't. I always have this. I may or may not have whatever of this I have. So, first order logic, you build sentences out of these in the way that you would expect. So, for example, this is a sentence. There is some x such that x equals itself. It's a stupid sentence, but it's a sentence. This is also a sentence, by the way. There is an x such that x does not equal itself. That's an equally stupid sentence, but it's a sentence, right? It's grammatically correct. I make no claim as to whether it's true or not, but it's grammatically correct. Here's another one. This one's slightly more interesting. For every x, there's a y such that x is less than 1. That's true. It's not as stupidly true. It at least has some meaning. We like there to be no largest number. But that's also a sentence. And anything that makes grammatical sense out of these symbols is a sentence. On the other hand, the following thing exists, parentheses, and less than x, parenthesis, parenthesis, is not a sentence. Right? There's a formal definition of what a sentence is.
Is that the not sound?
Which, this thing?
Yeah.
Oh, oops, sorry. That's another symbol for this. Depending on the author.
I was wondering why there was a
Oh yeah, sorry. This is and this is also and. There's actually also another symbol for implies, but nobody uses that anymore, or at least nobody's used it for the last 50 years.
Isn't it just 2 lines of arrow?
That's basically the same symbol. The weird one is that. Nobody has used that for the last 50 years, so.
Well, except for Robbie. What we do?
Robbie uses it?
Robbie does. Rob does.
Okay, whatever. I need to smack him something more than heavy. Okay. There's no good reason why anybody should ever use that symbol. I'm going to talk to him about that.
It's like being an indie mathematician.
Is it, wait, the...
It has the same aesthetic feel of
This is an and, that's also an and. We have two symbols for the word and, because we're stupid.
The first one is the British one. That's the one they use on the IB. That's probably why.
That explains where that comes from, actually. That makes sense.
It makes
I did
more
not know
sense
that.
because it's, for the opposite.
I prefer this symbol, but this one requires less explanation because that one we actually use in everyday life.
Yeah.
Either of them more. So there's the idea of a sentence, and it makes sense. And you could all probably recognize what is a sentence and what isn't by just looking at is it grammatically correct. So, one last thing. What the hell do I talk about using this language? Right? Anytime I want to do philosophy, anytime I want to talk about language, I need to at least ask the question, what am I referring to?
Sex?
For every x, there exists 2x.
Oh.
But not necessarily.
3.
This is one of those few times that I actually.
3.
Sorry. Carry on.
I'll start talking about finite symbol groups if you don't stop. So. Neil's gonna kill me now. So there's one last thing. What the hell am I talking about? Right? What do I use mathematical language to describe? This one's actually answerable fairly easily, and the answer's not very satisfying because it's not as clear, but it works. So, given a vocabulary, remember that's a set of symbols that I might not always have. It consists of maybe some function symbols like plus or times, some relation symbols like less than or whatever this hideous thing is, and maybe some constant symbols, right? Maybe I have a specific symbol for the number 0 or 2. So functions, relations, constants. Here's what I look at. A structure, it's a set where every single thing in the vocabulary is given a meaning. Each constant symbol C actually corresponds to some specific thing here. Each relation symbol, I don't know, R, right? Any relation where I plug things in and get either true or false, corresponds to some relation on this, some actual well-defined relation here, which I can't draw because relations are multiple dimensional, and I can barely write in one dimension, so that's not going to happen. But imagine fuzzy stuff over here. And a function corresponds to an actual function. So given every function symbol, I get some function from my set to itself. So basically a structure is just a set of objects together with meanings for every one of these symbols. Right? There's no reason you should assume this is satisfactory. It's very limited, but as a matter of experience, most of math can be put in terms of structures. There's no reason to believe that, but it happens to be true. It's often very hard. There are things that we talk about, such as the real number line, that are not obviously structures, but they can always be put in terms of structures. So for now, accept on pure faith that if we're going to talk about structures, we're good. All right. First order logic has two unfortunate properties, and I promise I will finish in the next 10 minutes. The first unfortunate property is that it is very weak. I can talk about some things, but I can't talk about everything, right? I can say there exists two things. Exists X, exists Y, right? That does it pretty well. I can say there exist two giraffes. I also, and slightly more relevantly, can say there exist two things, or there exist 4 things, or there are 8 things, or there are 16 things, etc. Because that would be an infinitely long sentence, right? That would look something like exists X, exists Y, or exists X, exists Y, exists Z, exists W, or, and I have to keep going forever. And I don't allow infinitely long sentences. So there are some things that I just can't say for first order logic. And there's a very famous theorem that characterizes what I can and can't say, called Gödel's incompleteness theorem, which is the reason Gödel was found behind a refrigerator clutching a frozen chicken. But I'm not covering that one.
Thank you.
Instead, I'm covering the much harder and more complicated Lindstromprt theorem. For the record, nobody's heard of Per Lindström in the last 2 years. Heard from or of, really. He's vanished. We have no idea where he is right now.
Where was he before?
That's
Holland, I think.
next to
Those Dutch.
Yeah.
Hmm.
So, on the one hand, I very much want something better than first order logic, right? On the one hand, I want something that's stronger than first order logic because it can't say everything. On the other hand, it has a couple